Okay, ready to go? Everybody awake now? So thanks for coming. My name is Bill Shetti. I'm Director of Public Cloud Solutions. And today what we're going to cover is, I don't know if you were here from the last talk, you talked about Prometheus and actually managing your cluster, right, from a Kubernetes perspective. I'm going to talk to you about how you actually manage your application now, and how do you get stats out of it, and how do you actually look at that on a Kubernetes cluster. How many of you use Kubernetes? Yeah, got 2-3 people in the background. How many of you understand Prometheus or Grafana or one of those components? Yeah? Okay. So just a little bit of a quick overview here and just some semantics, right? Whenever you deploy a cluster, right, in Kubernetes, it's a pretty vanilla cluster. You have to add a lot of componentry to this, right? And there's this whole section of what we call observability around that cluster. There's things like application stats, right, and cluster statistics, which a lot of people talk about. There's also log data and tracing information, right? And there's a lot of different ways to solve this, right? You can definitely use a lot of the off-the-shelf products and components within the actual cluster itself. You can load Prometheus in a cluster, Fluentd as an example, or even Zipkin to do the tracing. Then you can load Prometheus on top from an aggregation perspective to aggregate all that cluster information in one location, right? Now setting this up is not simple, right? Each one of the clusters has to have a Prometheus configuration installed. You probably have to run Grafana, like you saw in the last presentation, and you have to create an aggregation location, right? Including not just for the monitoring piece, something parallel and similar to that on the logging piece, with potentially Fluentd and maybe an aggregation location with like Elasticsearch, right? So at VMware, right, we have a little bit of a different take on this. If you think of Prometheus right now, it's not really a multi-tenant product in the sense that it only works in a single component, i.e. a single cluster, and you have to work at getting multiple clusters in there. We have a product called Wavefront, which actually provides out-of-the-box aggregation capabilities for statistics from multiple clusters, right? In addition, we also have a logging tool that takes an input from multiple clusters for logs. Now, in this particular talk, I'm going to specifically talk about how we'll use Wavefront to effectively monitor that cluster and that application, right? Not just from a cluster stats perspective, but actually get into the code, right? And show you how you can actually understand what's happening inside your application and pipe that information to Wavefront, okay? Now, we lost a little bit of color on this one. But anyway, I have a typical app here that I've generally created. I use quite a bit. It's got several different services, right? I have, inside of my cluster, I've loaded an ingress controller, load balancer, right? That allows me to get access to it from the outside. I've got an API service, right, which is effectively run using a replica set of an API Flask server, okay? Then I also have a Django server, which is where my main website sits, and a MySQL service. Now, what I'll specifically cover is how I'm going to implement application monitoring, let's say in this one particular component, right, which is written in Python, and how to get that information out of there and into Wavefront, okay? Now, if you want to see this configuration, there's a link on the bottom, right? My GitHub repository and location is all there, where all of this is detailed out, including all the code. You can take a look at it and then utilize it for yourself. The first thing you have to do with any of this is obviously make sure that you spit metrics out. Right? It's one thing to load Prometheus or something else into the cluster, and it pulls that information because Kubernetes already has it. It's a whole nother thing to effectively get that information out of the application, right? So the first thing you're going to do is, sorry, I got a little too far, is instrument your application, right? And in this example, because it's a Flask-based service, it's written in Python, I've instrumented it using a standard library, right, for statsd, and then I've enabled port 8125 to actually output some statistics, right? And so I'll show you what I did, and then we'll kind of walk through that example, right? Okay. And get into here. Oh, keeps logging me out. Give me a second. Okay. Okay. If you have a standard web server, API service, Flask-based server here, right? Added in a library called statsd, right? Stats client, right? Imported that, initiated it right over here onto port 8125, and you can find a lot of these sort of libraries around, right? Now, what I did is inside of my application itself, I've instrumented a couple of these metrics. I said anytime I get into this call, I put a timer in. It says this is how long this call will take. I also put another one in here for incremental timer, metric. Every time this comes through, it increments it by 1, right? So now I have a little bit of metrics around my API server, specifically around one API call, timing, and the actual times that it goes in. So that's been instrumented. I go and create my Docker container and everything, and I have a Docker image, right? So that's step 1, right? If you can't get that, then obviously there's issues. So once you've set that up, now you effectively have to go in and okay. The next thing you're going to do, and what we use, is something called Telegraph. And I'm going to go back to my slide here for a second. This is now outputting information to port 8125. And I've got a pod. But that's going into the pod itself. Something has to read it. Well, I'm going to use something called Telegraph, which is an open source product. You can go look on GitHub and find it. And it's going to listen on port 8125 for all of that output coming out of that Flask server, right? It's going to pick that up, right? And then it is going to output it to a specific location. But to set this up, you have to run what are called sidecars. You guys familiar with sidecars? Okay. So setting up the sidecar is a little bit tricky, right? And so here's my configuration, right, that I use, right, for my Telegraph sidecar. Now you can get this anywhere. You can also look at my repo and you'll find it. But I have a Docker container, right, that I have created, right, and specifically I'm passing in inside of the Docker file specific variables that I have embedded inside of the conf file for Telegraph. And the important thing here is I've pointed out a Wavefront Proxy, which is a specific output section to go to Wavefront. Okay, so that's all open source, right? I've also initiated what the interval is, and I'm using a 60-second interval for this, and I'm going to bake that into the image. Once that's baked in, right, and I create a container with this, right, I'm going to utilize that container now, right, and add it as part of my sidecar inside of my API server Kubernetes deployment. Okay, so here's the YAML from for Kubernetes for the deployment, and I'm pulling in an image that I basically preloaded, right, from the previous slide. Effectively created a container and I've loaded it into Google, right, into repository over there. I've noted the port that I'm going to be listening off of. I use that variable, right, which is coming in as an expected variable for that configuration, which is now inside of my my running image for Telegraph or in the container, and I give it a name, Wavefront Proxy, right? And Wavefront Proxy is another service that's running inside of my cluster that I bring up to effectively get that information, and that's what will actually go and actually push that information out. I give it an interval, and I give it 60 seconds, which overrides. I can make this 30, which overrides what's in the container itself. And then I turn on a few other components here. I want to get the node host name as an example and other bits of information like pod name and namespace. And what that does is it starts collecting that information from that cluster and specifically from that pod itself, that information, and what the namespace is. And you'll start seeing that in the metrics information, so you can identify this specific pod and or this replica that's running comparatively to everything else. right? And so there's little bits of information that help differentiate it. And so we add that into our YAML file, right? And effectively then you go to deploy this, right? And once you've deployed it, you'll see a pod, and inside of that deployment, you'll see Telegraph also running, finally listening to port 8125. And I'm going to show you what that looks like on the CLI here in a second. Give me a second, let me just get into my cluster. Okay. Okay, so here you see my application running right down here. I've got 3 API servers, right? 3 replicas running. I've got a MySQL service also, and I've got a couple of other things like a mobile server, and I've got the Django server that I talked about before. Let's just take a look at what's inside of one of the API servers. Okay, it's a lot of output, right? But here you can see, we'll start from the top of this, right? You'll see what's running, right? You got all the annotations, but here you see the first container, right? My API server is running. And if you look down here, here's the other one, right? Telegraph statsd. Now, if you're familiar with sidecars, you understand that they're basically now sitting on the same bus, listening to the same information in the same ports. You log into either one of these, you can do a netstat, and you'll see what ports each one is listening to, which is the same, right, to some degree. Okay, so that's running, right? And I can actually show you how this will look with, let's say, another one, or MySQL even, right? I've got a lot of this instrumented already, and then I'll bring some of this up. So this one's a little bit more interesting, right? So I have here MySQL, right? And then I've got Telegraph, right? Also instrumented here, just like that. In this actual cluster, I've got Istio actually running too. I won't cover that here. All right. So that's what your sidecar implementation would look like, right? At this point in time, I also have installed in here something called a Wavefront Proxy, right? And I'll just show you what that looks like. Okay, so I got a lot of stuff running in here, but you'll see here, right, there is a Wavefront Proxy running over here. That is the location, and that service is specifically where I'll get the service up, but in that pod, that is where the Telegraph agent is effectively sending its information to, okay? Now that is configured to send information to our web service, which is Wavefront, and that'll start collecting all that information. Let's go back to slides for a second. So I'm going to start there, and then I'm going to switch over to Wavefront for a second, but any questions around that right now? Okay, pretty straightforward? Okay. All right, so let's take a look at what we just did, right? And what this looks like. Well, the first thing is when we install Wavefront Proxy, right, it actually uses Heapster, right, underneath it. And Heapster, right, that it installs allows the Wavefront Proxy to first pull information about the cluster. This is similar to what Prometheus does currently, but guess what? You have no other configurations in Grafana or anything else, because as soon as you install that proxy, you get all of this information out of Wavefront like that, right? And I can come in here, and I can see all my nodes, my namespaces, the pods, the containers. I mean, gobs of information coming in, predefined, preloaded, very easy to use, okay? So that's great, but we didn't come here to talk about just that, right? So let's take a look at some of the information that's coming in. So one of the workers inside of this cluster, right, has about a bunch of stats coming in, right? Obviously, we can see that information individualistically, right? Or we can see it in the graph. But what I also have here, right, is if I just show you, right? There's about 200 stats coming in from this other node because I have a lot of my application running. And if I look for MySQL, right, you'll see all the MySQL stats coming out of that Telegraph sidecar, right? Here they are, right? I can actually come in here and let's take a look at something interesting. InnoDB, right? I can look at my buffer reads. I don't know. There you go, right? But remember the API server, right? That I built, that I instrumented for you guys. So here are the stats that Python code actually outputted now, right? So I've got my sign up, right? Time, that's for a sign up thing. That's another pull. That's another call in there, right? But here's my prospect pull, which is just telling me how many times it gets hit. Then I've got timers in here, right? And that one single timer piece of line that I put in before the call gives me a bunch of different values. I can get the total timer count. I can get the lower component of it, averages, the means, etc. Right? So now I have a rich set of information about what's happening with my API server, right? Inside of my Kubernetes cluster, and I can look at this, right? And if you look at this kind of interestingly here, right, you'll see right in here, I've got my 3 replicas. And you can see them all spread out and divvied up. And that was because inside of the Telegraph code, I put in the pod name, the node information, and the namespace, right? So now I can really distinguish what's happening inside. Okay. Okay, let's come back here. And just to summarize, right? Using Wavefront, right? We can truly now see everything that's happening on my cluster and my application and on multiple clusters very easily. So now you can see how if you have a multi-cluster deployment that's happening, you can get a rich set of information across the board, right? Using Wavefront on Kubernetes. That's it. Questions? Yes, those are the exact ones that I actually instrumented and showed you the code for. Here's the ones that this specific set was the ones that I put in the code itself. Yeah. No, yeah, they're embedded in Telegraph, yes. So it pulls it out automatically. I have to give it the I have to give it a username and password to get into MySQL so it can pull it. Yes, it can pull it. Yes, yeah.
Okay, what is positioning between Wavefront and VROPS in terms of Kubernetes monitoring?
I'm not a VROPS person. Okay, so what I can tell you is that number one, this is a time series analysis, right? Product. This is not about looking at. It's about looking at stats and metrics as opposed to monitoring. There's a little bit of a difference, right? Now, with Wavefront, it pulls that time series analysis. What I can do in this is actually I can go in and detect anomalies. And then I can, with an anomaly detection or a specific characteristic that I set up, I can then send an alert and say, if this occurs, or if this pattern occurs at any point, alert me at that point, right? Or if I see it building to a point, then alert me before it happens, right? And then I can look historically, find issues that have occurred, and then build up some sort of a rule deck around it and say, okay, if these ever sort of patterns occur, let me know. The problem with any sort of monitoring tool that you have, like Datadog or anything else right now, it's a post-actionary product, right? Something's happened, then you go do something. What Wavefront does is helps you analyze historical information to help you prevent stuff in the future, right? Or if it occurs now, then yeah, you'll have to see it. But the beauty of this, it's not just about one thing. I can take all of this information and cross-correlate it inside of Wavefront using a set of rules, sort of like a mini AI. Now, I wouldn't say AI fully, but yeah, right? Okay? Yeah, that's it. Thank you.